Hello everyone, my name is Arun Kumar Akula. I am working as a AWS DevOps Engineer at Aja Consulting Services. Today I am going to show you how to configure AWS Load Balancer with auto-scaling groups. Before going to do practical setup, let's quickly know about what is AWS Load Balancer and AWS auto-scaling groups. What is AWS Load Balancer? AWS Load Balancer routes the traffic between across AWS instances, and it ensuring that allows the traffic between only multiple instances, which is healthy. What is auto-scaling group? Auto-scaling groups helps us scale up and scale down the instances based on the demand, and it ensuring that high availability and fault tolerance. Let's understand about how the load balancer works with AWS auto-scaling groups. Here we have an users. When a user makes a request through browser, example amazon.com or myntra.com, so the traffic will be forward to the load balancer, and that load balancer directly forward to the target group, and this target groups collects the information about the servers like host name, VPCs and security groups, health configurations, and then so here we have an servers. So for these servers, auto-scaling groups and load balancer routes the traffic based on the target group. If a server will crash, auto-scaling group automatically detect and replace the server with new one, and load balancer will route the traffic based on the auto-scaling target group. Now let's dive into the practical setup. Before we go into practical setup, we need an AWS requirements like AWS EC2 instance and GitHub, and we need to clone the code. Here I am going to log in into my AWS console. I am logging my console as root user with my email address. Here I am giving password. Now here, this is my AWS console homepage, and here I logged into my AWS console, and here we are seeing that recently visited EC2 servers, S3, billing and VPC IAM. These are the resources of AWS console, and here I am going to create an AWS EC2 instance. Here I am checking is there any EC2 instances. There is no EC2 instances up to now, so I am going to launch an EC2 instance. Here we need to give basic details to create an EC2 instance. Here I am going to create an EC2 instance with any name, and here I am giving name as ASG EC2 instance. Here I am going to select an AMI. So this AMI consists of operating system. Here I am selecting Ubuntu, and here the instance type is T2 micro. I am using as default, and here I am going to select key pair, and here I have COPS key pair by default. Here I am going to create a network. VPC is I am choosing default, and subnet is I am choosing as 1C. Subnet available zone I am choosing 1C, and here make sure that auto assign public IP enable, and here we should make sure that SSH security group as SSH, and make sure HTTP. Remaining I am leaving as default, as configure storage and additional details I am leaving as default, and simply I am going to create an instance. Here we can see the instance is pending state, and we can see that the instance name is auto-scaling group EC2 instance, and this is an instance ID, and instance state is pending, and we can see is an public IP public IP and key pair name, and which is the platform like Linux, Unix, and we can see that available zone 1C. Now my instance state is running and my status is initializing. So I am going to connect this EC2 instance with the help of SSH client. This is my SSH this is my SSH ID to connect my EC2 server. So I am connecting through git bash. Here cd downloads. Here cd downloads. In cd downloads I have my key pair, so I am selecting downloads. Here I am pasting that which I copied from the SSH client. Now it will ask that, are you sure to connect? Yes. Now I connected to my EC2 server, so I am clearing. Now I am switching to my root user. Currently we are in normal user. Sudo su -. This is the command to switch to our root user. So this root user have everything credentials. Here now I am going to update my Ubuntu package. Apt update -y. So now it updating my Ubuntu package. See here, now successfully it updated my Ubuntu package. So I am going to install Nginx Nginx web server. So I am going to install Nginx web server because using this Nginx web server we are going to deploy an basic HTML code. Apt command to install Nginx web server, apt install Nginx -y. So this is going to create and install the Nginx web server. Now we can check the Nginx web server is installed or not using the command nginx -v. So here we are seeing that Nginx web server version is Nginx 1.240. So here by default we have by default Nginx path /var/www/html. So in that we can deploy our HTML file. Here I am moving to Nginx default path. Now I am checking is there any files in this path. So here we are seeing that index.nginx debian html. This is the default file in this path. So I am going to remove this path. Now here I am seeing that there is no files in this file. So I am going to clone my code. So here I am going to clone my code. Already I have in my GitHub an HTML and CSS basic HTML code. So git clone. This is my GitHub account, and here I have footer application. As we can see here, index.html and styles.css. This is my code. So I am going to clone this code by using git clone and URL. So it successfully cloned my code. I am going to check with the command with ls. So here as we can see that food app. So here cd food app. I am going to check whatever files in the food app is there or not. ls. I have index.html and style.css. So up to here we deployed our HTML code in the Nginx web server. So now I am going to access this application is working or not by using the public IPv4 address. Public IP followed by foodapp. Now as we can see here, our application is working successfully. So now I am going to create an AMI. So here I am going to create another EC2 instance. Before that I am going to create an AMI. Why this AMI? AMI is used to create an EC2 instance. Already we are configured in one EC2 server everything, right? So avoiding those configuration again manually, so I am going to create an AMI. Here I am selecting my EC2 instance and I am going to actions. In that actions we have an option like image and templates, and in that image I have option like create image. So I am giving name as foodapp. Description I am leaving optional. So here I am checking my storage as 8 GB. I am simply creating my image. Here we can see that currently creating AMI from EC2 instance. Here I am going to check my AMIs is installed or not, ready, creating or not. So here I am going to check AMIs is creating or not. As it's successfully creating and it is in pending state. We should wait until the status is available. So here as we can see that my AMI status is available, and here I am going to create, here I am going to launch an EC2 instance from this AMI. So I am selecting this AMI and launch instance from AMI. Here I am going to give a name as ASG LB server 2, and we can see that AMI ID, AMI name and username, and we can see that which root device and ENA label and architecture, and we can see that my instance type is T2 micro and selecting as my key pair, and I am going to create this server in another region as 1D, and here I am going to select my security group as HTTP. Simply I am going to launch. Now here as we can see that my server 2 is in pending state. Now it is in running state. So I am going to access this application Now here we can see that whatever I configured in server 1, so as that we can see those application in server 2. Now I am going to create an target groups. This is the target group homepage, and we are going to create an target group. And in basic configuration, I was selecting that instances and target group name as AWS auto scaling groups target group. So I am naming this, and protocol is HTTP and port number is 80, and here IP address I am selecting that IPv4, and VPC I am choosing the default, and protocol version is HTTP1. Health checks, here I am choosing that health checks path is /root. As now we can register these servers. I am clicking on include and pending. Now create target group. Now these target groups are unused. Now I am going to create an AWS load balancer. As we know that AWS load balancer routes the traffic across multiple EC2 servers. Here this is the AWS load balancer console, and I am selecting that application load balancer. Here I am naming that my application load balancer name is auto scaling load balancer. Here the schema is I am selecting internet facing, and load balancer IP address type is IPv4, and network as I am choosing the default, and I am choosing availability zones as and I am choosing here availability zones as 1D and 1C, because my servers are in these regions. And security groups I am choosing default, and listeners we can leave it as default HTTP and 80, and target group is AWS load balancer target group, already we configured before. So here we can see summary. What is the AWS load balancer name, and what is the schema and IP address type, and what are the network mapping we are choosed, and what are the security groups we are choosed. Everything we can see here, and simply create an load balancer. See here, this load balancer is creating, and is successfully created, and it will take some time to active the status. As we can see here, my load balancer is in active state, and we can observe that here DNS name. Whatever I configured in servers, I can access through the DNS name. Now I am going to create an launch instance. Now I am going to create an launch templates. This launch template is used to create the auto scaling group servers. I am going to create a launch template, Here I am giving a name as my launch template, and here I am selecting that auto scaling guidance, and here I am selecting AMI as my AMIs. Before I created AMI, right? So I am choosing that AMI, food name. And here I am giving as instance type T2 micro, key pair is selecting cops, and security groups I am leaving as default, and storage is I am leaving as default. So I am going to create a launch template, create launch template. Here we can see this. Here we can see that successfully created my launch template. Now I am going to create auto scaling groups. As we all know that auto scaling groups helps us to scale up and scale down the servers based on the demand. So I am going to create an auto scaling groups. Now I am giving auto scaling group name as my ASG group. Here I am selecting launch template which I was created before, my launch template, and we can see here my launch template are details, T2 micro and AMI ID and key pair name. So I am going to click on next, and it is asking now choose instance launch options and what are the instance type requirements. Launch template, my launch template before we created that, and version is default and instance type is T2 micro. So my network is I am leaving as default. I am choosing that availability zones. I am choosing that availability zones which are my service is running 1D and 1C. Here I am selecting availability zone distribution, balance the best effort. It helps to here I am choosing that availability zone distribution, balance best effect. It ensures that our application will be availability in our availability zone. Here integrate with other services. Here I am selecting load balancer which I was created before. Here health checks is the, here I am selecting health checks is the must and should to, here I am selecting health checks is the must and should to configure with the AWS EC2 instances because these health checks are monitor our EC2 instances. Here I am giving health checks grace period as 10 seconds. Click on next. Configure group size. Here desired. Here I am selecting that desired capacity of my EC2 servers, and here in scaling minimum desired capacity 1 and maximum desired capacity as 3. Here I am telling that if my server is crashes, minimum, here I am telling that if my server is crashes, the application should be available. Minimum desired capacity is 1 and maximum desired capacity is 3. So I am going to, so here I am going to click on next. Here we can add additional notification. This is optional. If we have any notification service, we can add this, and I am clicking next. If we want to add tags, we can add tags. Now this is the review page. We can choose our template, launch template, and this is our group details. My ASG group, my group name as ASG group, and launch template name, version, and choose an instance launch options, whatever we configure to launch options. So we can review here. I am going to create auto-scaling group. So here it is going to update capacity. It means it is going to create my auto-scaling group. So as we can see here, my auto-scaling group name, my launch template name and instances. Now instances is 0 because it is updating state, and my state is updating capacity, and desired capacity is 2 servers, and minimum capacity is 1 server, and maximum capacity is 3 servers, and availability zone I choose 2 availability zones. Now once we go back to our EC2 instances, here I have 2 EC2 instances. Now the auto-scaling groups will create the EC2 instances more. As we can see here, auto-scaling group launched and 2 EC2 instances. Now they are in running state and the status check is initializing. Now I am going to my AWS load balancer. Here we can see that my AWS load balancer is active state. So I am going to access my application using AWS DNS. As we can see here, as my output is Hyderabadi food delivery. So now I configure AWS load balancer and auto-scaling group, right? So this auto-scaling group can create multiple EC2 servers when my application is goes down, and this load balancer can browse the traffic between across multiple EC2 instances, which is healthy instances. So now I am going to test my application. Now I am going to test my application is working properly or not. So I am going to delete these all servers. So now I am going to delete these all servers because auto-scaling groups creates the new EC2 instances, right? So it can maintain high availability. So I am testing with the termination. I am going to terminate all my EC2 instances. Now my EC2 instances are shutdowning. Now as we can observe that auto-scaling groups are creating new EC2 instances. So here my instance state is pending. Now I am going to check my application. So here I am refreshing this application. As we can see that my application is still alive because this auto-scaling group and load balancer are maintaining high availability and route the traffic between multiple EC2 instances which are healthy. Now we can see that my instance state is running. So again I am going to terminate this instance, and again auto-scaling groups create new EC2 instance. See here my instance state is shutting down. And again we need to observe that my auto scaling group is creating one more EC2 instance, the state is pending. Now we can check that state is initializing. As we can observe my application server is running state. So I am going to check my application while with refreshing the application. See here, when I refreshed here, my application is still alive. Up to now, as we seen that integrating AWS load balancer with auto scaling groups, as we coming to conclusion, by using this AWS load balancer and AWS EC2 servers, we can manage our application with high availability without any downtime.